chose was a rattlesnake, and we chose to focus on the tail or the rattle of the snake. The mutation for the rattle occurs in the chromosome and DNA that codes for the tails. The DNA is changed by the mutation, so the snake has a rattle instead of just a regular tail like every other snake. So the rattlesnake has a rattle now. The benefits of having the mutation to have a rattle is that it allows the adapted snake to better survive by using the rattle to scare off predators like the human. This will help them survive better and be more fit. This isn't actually Cory, this is Brett. He was speaking too quiet, so I did a voiceover. Here we have a snake. Here we have an earlier reptile ancestor to the snake. It is in the desert. Here's a predator. It's looking for its food. Bang! It's found its prey. This is a struggle for existence for this animal. The ancestor needs to adapt and find a way to survive. The population is really low and gets the mutation to have a rattle to scare off its predators.
So the snakes kept getting eaten by these predators or killed by the predators. So after a while, they adapted and they got these fancy little rattles on their tails right here. This is a crude drawing of what it would look like. But so they got these rattles, and that was able to scare off their predators and also gave them a little advantage over their predators. And so this also became survival of the fittest, because those who didn't have the rattles were killed off quicker, and they didn't live long enough to reproduce, and thus having the rattlesnakes that we do today as popular as they are.
To show evolution, you need to show evidence. So our first evidence is two fossils we have. So our first fossil right here, you can see that it didn't have a rattle when it was alive. See, look at the tail. You can see the tail, it goes into a point. That shows that it didn't have a rattle. But on the second one, you can see right there that it did have a rattle. And you can show that this fossil adapted to its environment and grew rattle to scare away its predators. Over long periods of time, the DNA sequence in the snake changed. It came from a snake with a tail to a snake to a rattle. This evolution happened in the DNA, and this snake adapted to its environment, so it has a rattle to warn its predators from being eaten. This snake has similar DNA sequences to its early ancestors, which had a tail, but this one, the DNA sequence changed and caused the mutation so it can have a rattle. You can see the rattle right there. This one does not have a rattle. Different snakes have lived in different environments for thousands of years. The snakes have adapted to this with their body's characteristics. With the rattlesnake, it has adapted by making a rattle to help them stay away from predators and to camouflage into the sand so it can't be seen. But the jungle snake only uses camouflage, as uses the color green to camouflage from also predators, but these snakes change to their environment and shows biogeography through that. Here we have a Arizona prairie rattlesnake. This rattlesnake has a rattle, as you can see right there. The snake has adapted from throughout millions of years. Millions of years ago, rattlesnakes, or their ancestors, didn't have any rattles. None of them did. But they adapted to their environment and their predators so they can better survive by scaring off their predators and to be more fit. Here's our citations. Here's the first one. Our second one. Our third and last one. As you can see, we used many citations.